Good evening, sir.
So hello everyone, can you hear me? So I was waiting. Hello? Yeah, am I audible?
Yes, sir, you are.
Okay. So I think if any one of you do not have, so I've also started this. Let's see whether it's started or not. Yeah, the stream has also started. So can anyone? So I'll just share that video link. So this is the folder, one folder, and the other one. Okay. So can anyone confirm that the YouTube link is audible too? So if that is good to go, then we can start. So if that is, we can hear or something there as well. So if there is no audio issues or video issues there.
Nothing, sir.
Oh, it's okay, right?
Right, sir.
Okay. Don't call me sir, so please. So I'm much younger than you are.
Okay, thank you, sir. Thank
You
you.
can call me Moinak.
Okay.
Yeah. So yeah, let's start. Yeah. So last time, what we were doing is we introduced functions, and we saw various properties of functions. We also did a couple of examples for range and domain and so on. So this time we would continue. So is there any question? If there is a question, you can ask. So I think somebody is unmuted.
I can hear you.
Yeah, I think you are unmuted. Can you please mute while you're... I think your audio is on. So there's...
Now it's okay?
No, audio is on. I think I'll just mute you.
Okay, please do that.
Yeah. So yeah, let's start. So we'll start from the place that we left last time. I had asked you to look at this problem. So of composition. So we were looking at functions of functions, where we would map the domain of one function, and then we would in turn map to the, so say this is your g of x, so your x will be going through the g operator, and then g is you can think of it as we were talking about, as a machine that outputs a number to it, and then you can use it, that g of x output goes to f to give you an output. So as I told you to try it last time, so I'll do it this today. So let's try this one. So first of all, plotting these graphs would be useful. So let's do that. So these, you can see that fx has a domain of 0 to 3, where both 0 and 3 are included. And let's see what's its range. So this Let's just plot f of x first, and then we'll see how to do f of x. So for example, so here you are seeing you have 0, you have 1, you have 2, 3. So 0 to 3 is your domain, and similarly your range would be 1 plus x for 0 to 2. So 1, 2, 3, 4. So the 1 plus x is a line passing through 1 with an angle of 45 degrees is the slope of the line, right? So it's y equal to mx plus c. You can see that. So that's the, if you plot this, so it's a line joining 1 and 3. Both these points are included, right? So at 0 it's 1, and 2 it is 3. Similarly, 3 minus x would be from 2 to 3, right? So at 2 it is 1. Similarly, 2 minus x has this. So if y is equal to 3 minus x, so the intercept of this line is 3 and with a minus 1 slope. So this is something like this, that goes to 0 at x is equal to 3. So since it is defined for only 2 to 3, we would take only this part. So it's open here. So I showed you how to draw open graphs and closed paths. So this is open at 2, means it at 2 is not in this function, we add this piece of the function, and here 2 is with the other piece. So this is the graph of fx. So if something is unclear, so the range of this, can anyone tell me what is the range of this function? From there, the domain is 0 to 3, the range would be? So from the graph it's clear, right? So if someone can tell if it is it 0 to 1? I don't think so. So what values does this function take? Mr. Last time it's, I think, 0 to 3, right? So for 0 to 2, the function goes from 1 to 3. As you can see, at 1 this is 2. So this is 1 plus x, and this is 3 minus x, right? So you have two parts to this function, right? So this function, when the value is 2, it takes value of 3. So this is between 0 and 3, right? Did you understand, Mr. Pandey? It's 0 to 3 and not 0 to 1. If you have doubt, you can unmute and ask. So okay, I see no one responding. So is it clear how did I plot this this function f of x? I plotted it using two lines. So we know that a line can be plotted like this, right? Y equal to mx plus c, where c is the intercept of this line, and aim is nothing but tan theta, that is the angle with the x-axis. So I guess it is clear, right? So let's try and see. So if I see no one stopping me regarding this, so let's try to plot f of.
Excuse me.
Yeah.
Can you? I mean, my screen is very small. I don't know. Everyone is appearing, which I don't. It's not interested to see other pictures, other screens. My screen should be bigger. It's very small, so I can't it.
So you can change something called the change layout option.
Yeah. More actions. I have gone to them.
And you can put something like a spotlight or something. So it will be something bigger, I think.
Okay.
Yeah. So let's. So there's a. Okay, so let's try to do this. So what will we do is, so you see that this function is being plotted from 0 to 3 to it's going to 0 to 3 only. So if you see that if you apply f on that function, there is no problem because the domain is still the same. So you don't need to restrict your range in any way. So it's the same. So you can go on applying f as many times you want. So let's see now how can we do that. So last time one of you had told me, so if a function is f of x, right, that's your f composed of fx. So we can write, instead of, since this is the argument now, instead of x, I'm using this function definition, I'm writing f1 plus f of x, where f of x, wherever there is x, I'm putting f of x, because f of x is the argument to the function f now. So this, we are almost done, right? So we know the definition of f of x recursively. This is the definition. And if we can know the region in which the function of x, or the range of x, is between 0 and 2, and the range of the function is between 0 and 3, we can write those functions in form of that, right? So at what value of the function is between 0 and 2? So can anyone tell me what values of x does this function take values between 0 and 2? Is there any subcase or something to this function? So for example here, so if f of x is taking, my question is, at what values of x does it take 0 to 2? So 0 to 2 is something like, you need to draw, this is the region, right? 0 to 2. F of x between 0 and 2 is this part. If is that clear? So clear, this is the y-axis is plotting the values of the function. So this is the region in which the function is 0 to 2. So for what values of x is the function between 0 to 2? So there are two cases here, right? So if x is between 2 and 3, then the function value is between 0 and 1, right? There is one division here. So this is your case 1. And the second case is between when the value of the function is between 0 to 2, or in this case 2. So we have got 0 to 2 to 3, the function takes values between 1 and 2, right? So if to be exact, the function is between 0 and 1 for this, by the definition of 3 minus x. So until if it's not interactive, it becomes a bit challenging. So anyway, so we'll do the second part of it. So if the function is also between 1 and 2, so we have seen the function between 0 and 1, right? So from this we need is a function belonging to 0 to 1 to 2 now, to complete this first case. This is the first case. So what will it be? From 1 to 2. So 1 to 2 is taken when the value of x is between 0 and 1, right? Somebody told 0 and 1, that is correct. So between 0 and 1, this function takes values between 1 to 2. And case 3 can be, or here the big 2 case, is also when the value of this function is between 1 and 2. This function takes a value of between 2 and 3. I may be a bit sloppy with the open interval and close interval sometimes, but we'll figure it out at the end. So let's see now. So we can write f of x. So we divide the first case 1 into two parts, right? So 0 to 2, where the function was between 0 to 2. So we had these two conditions, when x is between 0 and 1 and x is between. So this is one condition, when the x is between 0 and 1. Both are included as far as I see. Yes, both are included. And in that case, this condition of f of x is valid, right? So you had from here, I'm doing this step. So f of x, I'm putting the value of 1 plus x. Because it's between 0 and 1, f of x is, you can see it's 1 plus x. So it becomes 2 plus x between 0 to 1. Similarly, when the value of x is between 1 and 2, so what do you have? 1 and 2, you have 1 plus f of x. Again, so I'm writing this in blue. Green is the final output of this f of x function. And this is the working that I'm doing in black. So it's 1 plus f of x again. But now, for what values of f of x? Between 1 and 2, right? So for between 0 and 1, which function is the value taking? So from between f of x between 1 and 2, the function is taking 1 plus x value. So I've been I think there's a problem here. So nobody pointed this out. So between 0 and 1, which part of the function does it take? It takes, this is between f of x is between 0 and 1, right? F of x is between 0 and 1 means x is between 2 and 3. This is why there's been a problem. So okay, we'll just, so f of x, I'll just write it here. So f of x is between 0 and 1 means this is this part. So x is between 2 and 3. So x between 2 and 3, I'm getting from this case, is 1 plus f of x. And what will we put? We'll put this value, right? Because this is 2 between 2 and 3 that the function value takes between 0 and 1. So the steps include, there are two parts to this function. So function of between 0 and 2 and function between 2 and 3. So from 0 and 2, there are two cases that the function takes. So one case would be 0 to 1, that is taken when value of x is between 2 and 3. You can see from the blue circle that I have plotted. And at that point, the value of the function is defined by 3 minus x from this definition. So I'll put the value of 3 minus x. So this will become 3 minus x. So this becomes 4 minus x. Second part of this function, so this is 4 minus x between 2 and 3. Similarly, the function value between 0 and 1, when the value of x is between 0 and 1, is obtained from this case, right? So function value of 1 and 2. So that is also, so function value between 1 and 2 is also from this case. So you put 1 plus f of x. And f of x between 0 and 1 is defined by this function. So I'll come to your question between this part. So it's 1 plus 1 plus x. This is 2 plus x. And the last part is between when the value of x is between 1 and 2. Where this is between 2 and 3, it's still 1 plus x, right? So 2 and 3, this is this part of the function. Oh, I think, yeah. So this f of x is between 2 and 3 is between when the value of x is between 1 and 2. You can see from this, f of x is between 2 and 3 when the value of x is between 1 and 2. So you can get this as, this is also your 1 plus x from this part. This function is 1 plus x. So you will get 3 minus, this part is 3 minus f of x. So this becomes 3 minus 1 plus x. So this is 2 minus x between 1 and 2. So let's, okay, there's a raised hand. Go ahead. Sure.
Excuse me, sir.
Yeah.
Uh, See, everyone, all the participants are appearing on my screen, which you can control from your end. From my end, it is not possible because you are the host.
You want all the participants to appear on your screen.
It is appearing, already appearing. I don't want them because otherwise the whiteboard is becoming very small. I cannot
Okay.
keep teaching.
Okay. Is this okay now? But I can't see raised hands if this happens.
See this one. It's still only all the participants are appearing.
No, that has to be done on your side. So now I have removed this. This is my screen sharing option, right? So you have to do change layout and you have to make it auto or something. You have to make it spotlight.
That is not appearing, but since you are the host, you can control that thing.
I can't control it from your side.
Anyway, continue, sir. Sorry.
I think there's this more options is there. You can click on these 3 dots, more options one, and then you will have an option called change layout. Near the end call option.
Yes. Change layout.
And then you click on spotlight.
Spotlight.
Yeah.
Okay.
Is it working? Yeah. So the f of x function. So let us.
But still, it is whiteboard is not appearing now.
What
now
is
the whiteboard is not appearing.
What is appearing?
Just yourself. Just yourself and myself. Your whiteboard is not appearing now.
So you can try sidebar once. You can spin the screen as Tanushri Mehra is telling. You can pin the screen. There's an option. You click on the screen where the video is being presented. This screen is being presented. There's a pin option.
Yeah.
This yeah.
Right. This one.
Yes.
No, but still the I need to see the whiteboard. Your whiteboard is not appearing.
So there's a chat. You can go to the participants. And you will see that.
So I mean to everyone to be.
You can press the screen twice. That will do.
Achha. Let's see. Anyway, continue, sir. For me, others being disturbed, so it's better you continue. I have the books. I can take it there.
No, but can you do one thing? Can you follow the like mute this thing and follow the YouTube link? Then you will get the entire screen.
Okay.
I have
So
this. I'll share.
Come out of this link and follow the YouTube link, right, sir?
Yes. So I think then you will get it. But you do not need to exit the chat. You can stay in the chat and then in the meeting, but switch off the audio. So okay. So let's put it back here and try to plot the function to see if we have got it correct. So we have written f of x as, this is just a bit of housekeeping that you need to do to solve these questions, and then otherwise it's very simple. Yeah, so between 0 and 1, between x between 1 and 2, you will have 2 minus x, and between 2 and 3 you would have 4 minus x. So let's see. There may be a lot of doubt regarding this question. I'll solve them one after the other. Once you ask your doubts, no problem. So this is 1, 2, 3 and 4. So between 0 and 1, it is 2 plus x, right? So this is something like this. So this is blocked here. So this is something like this. And between 1 and 2, it is 2 minus x. So if the intercept of this line is at 2, so it will be something like this. And finally, for value of x between 2 and 3, you will have between 2 and 1. Right? 4 minus x, so 4, this is something like this. This line will catch at 4. So you will have a line between at 2 and 1. So this is the function, right? So let's check once. So first part of the function between 0 and 1, it's 2 plus x. See, you put value of 0, you get 2. At put value of 1, you get 3. Second part of the function, put 2 minus x, put 1, you get 1. You put 2, you get 0. Third part of the function is between 2 and 3, and that is 4 minus x. Put 2, you will get 2, and put 3, you will get 1. Now the question, is it okay, Mr. Prabhat? I think now you are able to see, you're using some companion mode. So I think you'll be able to see with the YouTube link. So anyway, so let us plot this using Desmos and see if it is correct or not. So I'll just do that. Let's just like we were doing last time. So because this was the thing that you needed to do. So let's see. So for example, say we have, let me just use the keyboard, f of x. So f of x was defined as between 1, 0 and 2, between 0 and 2, this was 1 plus x, comma, between 2 and 3, between 2 and 3, the value was, I think I remember it as 3 minus x. So yeah, this is the function. So what is now this? Now is the check whether we are doing the operations correctly, whether we have used the concept properly. So f g of x, let us define as f of x. See, is it correct or not? It is correct, right? So it's matching our answer. So between 2 and 3, between 0 and 1, it's from 2 and 3. Between 1 and 2, it's between 1 and 0. And between 2 and 3, it's between 2 and 1. So there has, if any, now is the time to understand what are the doubts regarding this question, how we are going about it. So I would request each one of you who has doubt. I see it's a bit silent today, so I would request you to come to us to so Mr. Pandey is selling, it's brilliant, so it's matching, so it may be, but I'm not able to understand whether I have been able to explain it. So we did a couple of steps. So what steps did we follow? This is for any composition. So this is why I told you how to draw graphs the last time. So first step what we did was we plotted f of x. Part 2, what did we do? If we had to do something like g of f of x, we replaced definition of gx with replacing x with f of x, and then seeing part wise where the functions are actually. So only I see one person understood. So if you have any doubts, you just come and ask me. So otherwise we'll have to go to inverse functions and all. So we'll be going ahead. Okay. So did you? So the question was, did you understand the definition of the function first? So I would request you to unmute and speak, so it will be helpful. The chat is not that visible because I've reduced the size of the screen.
So it is becoming a bit confusing. Can you please explain it throughout?
Okay.
Again?
So at what part did you lose track of it? So for example, did you understand how did I plot f of x?
Yes, sir. A bit of it I understood. The first graph.
Yeah, the first graph you understood, right? So let's redraw the first graph again. So can you tell me? I'll just see this. This is gone, I seems. So what was the regions? So it's between 0, 1 and 3, right? 0, 1, 2 and 3.
Yeah.
And this was between 1, 2, 3 and 4, right?
Yes, sir.
So, and the first part was between 0 and 2. So, and we had defined this as 1 plus x, right?
Yes, sir.
So this was between 1 plus x. So it's between 0 and 3. So this function was something like this, right? And the second part of the function was between, yes. So you understood this plot, right? So this is 1 plus x and this is 3 minus x. So this is nothing too complicated. This is just your class 8, 9 equation of a line, straight line.
Yes.
So now you are telling me how do you plot f of x. That's the problem you are a bit confused with. But you have, last time you only had suggested, so according to the definition I just put the value of f of x in x. So the definition was 1 plus x, right?
Yes.
So it was between, so wherever there is x, we are replacing that with f of x, right?
Okay, sir.
And then the second part was 3 minus fx, right?
Yes.
And this was between 2 and 3, right?
Yes, sir.
So now what did we do? So you just now for this function, so f x between 2 and 3. So we can solve the inverse problem and get the values of x, but I won't do that. I want you to find it graphically because we'll go to inverse functions next. So there are 3 cases, right? So here I'll just show you the first case. F of x between 0 and 2, right? This is one case.
Yes, sir.
So see. So between 0 and 2, f of x means we'll consider this vertical line, right? Anything below this is correct, between 0 and 2. This is the region we are interested in, right?
Yes, sir.
So how many parts do this graph has? This has 2 definitions, right? From between 0 and 1 you have one definition, and between 2 and 3 you have another definition, right?
Yes.
So f of x is between 0 and 2 at 2 places. So I divide this into 2 cases, right? Case 1 point A and case 1 point B, where the value of x is between 0 and 1, and here the value of x is between 2 and 3. Now it's clear. So that there was a lot of jittering there, so it may have been a bit unclear. Now this solves this case, like, right? First case.
Yes.
So now from the first case I have 2 values of x. So between 0 and 1 and between 0 and 2 and 3, right?
Yes, sir.
This is from case 1a and this is from
Yes.
case 1b.
Yes, sir.
Now you tell me, according to the definition, so this also has to be 1 plus f of x, right? This also has to be 1 plus f of x. That's how it's defined. In this range, it
Yes.
is 1 plus f of x.
Hmm.
Okay. So now what is the value of f of x between 0 and 1? How is it defined?
1 plus x.
Very good. So it's 1 plus x, right? So
Okay.
it's 2 plus x, right?
Yes.
And in this part, how is f of x defined? In the second part, between 2 and 3?
3 minus x.
Correct. So that's how you get 4 minus x, right? And for the middle part, this is nothing but this, between 1 and 2.
Yes.
So there's nothing to do here. Between 1 and 2, it's always 1 plus x. 1 plus
Yes.
fx, 1 plus fx, and the definition is also 1 plus x. This is why I'm telling you, concentrate on plotting graphs. So that will help you a lot. So that is, I think I made a bit of a mistake. So 1 plus 2, can you just point out what was the error between 1 and 2? 2 and 3 is done. Oh, sorry. This is between 2 and 3, right? F of x is between 2 and 3. So this is the problem with missing steps. F of x is between 2 and 3, right?
Yes.
From this part, case 2, this is 1 and this is 2. Not x,
Yes.
x is not between. So this is this part of the graph, right?
Yes.
So that is defined as 3 minus f of x, right?
Ah, yes, sir.
So that is between f of x is between 2 and 3. Not x is between 2 and 3. X is between 1 and 2. That we have obtained from this. So if you see this part of the graph, right? X is between, 1 and 2, right?
Ah, yes, sir.
So now what is the definition of f of x here?
1 plus x only.
Yes. So it is 2 minus x. So now is this clear to everyone? So now,
Yes.
so it becomes 2 plus x, 2 minus x. So this is how we have defined, and 4 minus x. And we see, so we could have easily done it algebraically, which we'll be doing next, but this will always help. This will solve all problems of making mistakes. Just now we were going to make a mistake by putting value of 1 plus x here. So it is not 1 plus x because this part is remaining. So because we are seeing f of x and not x. F of x is we have to see along y, right? Along the y direction to see see f of x. That's the idea. So now I think it's clear to all of you, right?
Yes. Thank you.
Sure. So let's go to inverse functions. So let's do away with composition. That is some mental ability that you need to do. Now is more of a definition. So last time, do you remember we defined one functions and onto functions, right? So when a function, so I have drawn a plot from A to B here. So every element is mapped to another element in B. So you can see my definition. F of 1 is B, right? F of 1 is your B. So this is your first mapping. F of 2 is D, right? See the mapping. And f of 3 is C, right? So for every element in this is a domain set, every element in the codomain set has to be linked 1 1, and so the size of the codomain set has to be size of the range set. These things we have defined last time. What does a bijective function mean? Where your two things must have 1 1, that is injective, and onto, that is surjective. Two things must hold. So what would be, there are two, I'll come to that. Why do you need these two conditions? For example, what would be f inverse of B? request someone to tell what is F inverse of B. So B, this is F1 is the mapping from 1 to B. F inverse will map from B to A. This is very intuitive. You don't even need, yeah, this is 1. So this will just, you take the reverse path that you took to get from A to B. This is 1. Similarly, so if this is F, this is F inverse. Similarly, what would be F inverse of C? It would be 3, right?
Yes.
Similarly, F inverse of D would be 2. So can anyone tell me why do we need this injective and onto and surjective clause? Let's draw general function. Yeah, go ahead.
So maybe we need only one solution for it, otherwise we'll get 2 and we'll take inverse.
Very good.
If one.
It will no longer remain a function then, right? We had spoken about it last time. So for example, I have 4 objects, 1, 2, 3 and 4, and I have say 5 points like this, or 6, whatever, A, B, C, D, E, F. So I define 1, this as a function, 3 to C and 4 to D, right?
Yes, sir.
Requiring bijective, need. So let's say, so the function is a mapping from your domain set to your codomain set, right? So what
Yes.
happens is, so for every value in the, what did we say, for every value in the domain set there has to be an image in the codomain set, right?
Yes.
So now your F inverse is a mapping from B to A. So now, does every element in the B set have a pre-image in A?
No.
E and F does not have. So it's compulsory to for every element to have a pre-image. That's exactly right. So first condition becomes range has to be equal to your codomain. There can be no element in the codomain set that is left unmapped from the domain set. So this is also known as the surjective function or the onto function, where the domain is mapped onto the codomain set fully. The other function would be 1 injective function. Now if I'll give you an example, F inverse of A, what will you say? You will have to say 1 comma 2, right? So this is no longer a function, not a function. So this is also has to be 1. It has to be 1 function. So it has to be both 1 and onto. So thus it becomes a surjective function or a bijective function. Surjective, so this is also known as an injective. So both actives are there, so it's also called as a bijective. Both surjective and injective is there, so both the conditions are being satisfied. So it's a bijective, injective, or known as a bijective function. So this is a good place to tell you what is a good check for seeing if a function is 1 or onto. Remember this. So we don't even need to remember. You can see this graph. If a graph is monotonically increasing, will it be a 1 function or many to 1 function? Increasing but decreasing.
Increasing.
No, both increasing and decreasing functions. Will it be a 1 function or a many 1 function? This is a decreasing function, this is an increasing function. So what did I tell you last time? How to check whether the function exactly. So the horizontal line test will tell you whether two values. So had this function been like this, so for the same value of y, you had two values of x. But this is not like this. So if you draw any horizontal line, does that cut your graph at two regions? So it doesn't, right? So it cuts at one region for both these two functions individually. So when you have increasing function or decreasing function, there is no coming back. There is no increasing, no decreasing. So if you draw horizontal lines, everything that is below it will remain below it, and everything above it will never come back. Is the intuition clear? So this would in turn become a 1-1 function. Similarly, a function is defined over whole surjective. You will have to see the range of the function. If the range is same as the codomain, so this is a very good check. If a function is, if and only if this is 1-1. If and only if means if a function is 1 and 1, then it's a decreasing or an increasing function. If a function is an increasing or a decreasing function, it's a 1-1 function. That's it. That's the definition. It has to be monotonically increasing. This is also an increasing function, but this is not 1-1 because this is constant at a particular. This is just increasing function. This is not monotonically increasing function. This is at this region it's constant. This is not 1-1. You can see the horizontal line test. So this is an important word. Monotonically increasing means f of x is greater than f of y if it is for increasing, if y is greater than x, right? F of y is greater than f of x if y is greater than x. So if your value of y, two numbers are there, say 4 and 5, the function would give a larger value for 5 compared to 4. That's an increasing function for any pair of numbers, for any ordered set of numbers. That's a monotonically increasing function. I thought it's a good place to introduce it here. Yeah. So let's try a simple example. So there is a hack, since we are a lot of this is being interpreted graphically. So let's see, inverse functions are also images across y equal to x, right? So how can you check that? So look at these two graphs. Let's say that this is f inverse, defined as f inverse of f of x is x, right? So f of x would map a point to, I'll show it here. So say f of 1 will map it to some a, and f inverse will map f of a to 1. So if you take f of x, you go to the domain set and come back to the same point. So I mean f inverse of. So look at 2 points here. This point, for example, that is x comma f of x, right? X comma f of x, because at the value of x, so the green curve is your, I'll do everything then this and in blue. So the green curve is f of x function. So for a particular value of x, any point on that curve would give me f of x. So this is your f of x for x, if you draw a vertical line. Similarly, if we project it to the y axis, so this is your distance is f of x. So this distance is f of x, right? So you plot the distance that a function gives along the y axis. So now if I plot a square, so if I put f of x on the x axis and project it upwards, so you get your x axis to be f of x, and at the point it meets f inverse, that is f inverse of f of x. So point P1 is, this is your P1 and this is your P2 is f, this means point P1 is f of x comma f inverse. What is f inverse of f of x? I am purposely doing this so that you see why are these mirror images about the x is equal to y axis. So why, what is this? F inverse of f of x, that is x, right? So f of x inverse is an opposite operation. For example, if f of x is x plus 2, f inverse of x would be x minus 2. So whatever you are doing, you would just reverse that step to get back the original value of x. For example, I'm giving an example here. So f of 1 is giving you a. So f inverse of a would give you 1. That's the idea. So now you see between P1 and P2, clearly this is if you draw a line between P1 and P2, that is perpendicular to y equal to x. Why? So you see, calculate the slope of this line. So it's y2 minus y1 by x2 minus x1. So it's f of x minus x. This is y, I'm taking this y2 minus y1 by x2 minus x1. This is minus 1. So m perpendicular, right? So y equal to x has m is equal to 1 because it's y is equal to x plus 0. So here m is 1. So we know m1 m2 is equal to minus 1 means that they are perpendicular lines. So you see, if you take these points together, so you have the inverse point f of x and f inverse x being mirror images. Yeah, go ahead. Yeah, there's some question? Okay, no question. So this shows that your f inverse is a mirror image across y equal to x or f y inverse x. So let's do some simple problems of this. So this is just to give you the geometric interpretation. So this will be useful. If you take the mirror image about y equal to x, you would get a inverse function. That's the idea I wanted to portray through this. So let's, for example, use this function. So f of x is equal to x into 4 minus x. And we have said it's between 2 and infinity to minus infinity to 4. What does that mean? So let us plot x, this function first. So can anyone tell me what this function looks like? We have discussed it last time. This is a quadratic, right? So what is f of 0? It's 0, right? Similarly, f of 4 is, we discussed this last time. 4 is 0, 0 is 0. Yeah, it's an inverted parabola. So we had first seen so this is 4x minus x square. Something like this. So this is your 4. Yeah. So we discussed that anything above 4 would be negative here, right? So because 4 minus x is less than 0 for x greater than 4. So it's negative. Anything less than 4 and between 0 here is positive. As we said, if for even powers we have change in no change in signs, and in odd powers we have change in signs of a function. And this is a quadratic function, so quadratic functions are always inverted. So this is how x into y minus x looks like. So can anyone tell me whether it is a 1-to-1 function or a many-to-one function?
Many to one.
Many to one, sir.
Correct. So because you take the horizontal line test and you see it cuts this into two parts. So for this, will f inverse be defined directly? It won't be, right? So this is why your domain is given from 2 to infinity. Did you understand? At 2, it reaches this maximum, a value of 4. When we'll go to derivatives, you'll understand. is the midpoint, so you can visualize it that way. So that will be the maximum value. So if you put 2, it's 2 minus 4 minus 2, that is equal to 4. So this is why. Now if we remove this part, so this is how you make non-invertible functions invertible. So why did I do this? Because this week we had trigonometric functions. So trigonometric functions inverses have to be defined this way. So you remove this part of the function to make it, you remove this. So once you remove this, it becomes a 1-1 function. So what will it become? It will become something like this, right? So 2 to infinity. And your object output is also from 4 to minus infinity. This is why I'm telling you, please try and practice graphs. This is your new function. So here you see there is nothing. There is no, this becomes a 1-1 function. And also a surjective function, because not entire real number line. It's between minus infinity. So it can take values between minus infinity to 4. See the graph, see the extent of a y-axis. It can go from minus infinity to 4. That's what has been written here. So now it becomes a 1-1 function and also a onto function. Now is the inverse defined? So we had a lot of students last time. So we had almost 30. So this time people are not joining. So will it be like this going forward? I don't know. Anyways. So does this become a bijective function? Now?
Yes, it is.
Yes. So now we can write an inverse of this. And how do you write an inverse? In finding an inverse is a very simple problem. It's very simple. How do you do it? Say instead of writing f of x, I write this as y. Yeah. We write it as y and I write it as x into 4 minus x. So the procedure is make y the independent variable. This is why I was telling I could invert the inequalities that were I presented in that diagram, but I wanted you to visualize. You could directly do algebra, but that does not give you intuition. Correct. Very good. So it seems that few of you know the process. So let's see. So y is equal to 4x minus x square. So what would be the trick here? The trick would be to complete this square. So this is a very, very well known formula. So our middle school formula. So do you remember? So this is x square. So if I put a minus sign here, minus 4x plus 4. And if I add 4 to it. So what is this? This is your x minus 2 whole square, right? Y is equal to minus of x minus 2 whole square plus 4. Next, what do you do? This is just algebra I am doing. So I move this to the other side. So I get x minus 2 whole square is equal to 4 minus y. Now I get x minus 2 as 4 minus y. So let's write it at the end. So this is the solution. So put it at the end now. So sorry for that. It is requiring a little bit more space than I anticipated. So anyways, 4 minus y is equal to x minus 2 square. So I take square root on both sides. So remember, your function is defined from 2 to infinity, mapping to 4 to minus infinity, or minus infinity to 4. Sorry for that. Minus infinity to 4. Similarly, I'll take the root over 4 minus y. This will become x minus 2 is equal to plus minus this. So this becomes x equal to 2 plus minus 4 minus y. Now you see, values your function can take have to be from 2 to infinity, right? So the inverse function cannot give you. So your inverse, f inverse have to be between, this is the algebra what is telling you, but the inverse function has to be between minus 4 to minus infinity to 4 to 2 to infinity, right?
Yes, sir.
But can we take minus then? If we take minus, so you will have negative. So for example, 2 minus 4 minus y, if we take the value of say 6 minus 16, which is a valid number here, because minus 16 is between minus infinity and 4, so it will, or minus 21 say, so this will become a 2 minus root 25, it will become negative, right? Minus 3. So you can't take the negative part of it because it has to be greater than 2. F inverse has to be greater than 2. So x, you only can take the positive part, 4 minus y. So this will not be there. So now what you write? You replace x by f inverse of x and y by x. This is your final step. That's it. That's the algebra. So this is your f inverse function. So now it's your task to plot this function for me. We had seen this function. My question, your question is assignment 3 would be done. This is week 2, right? So we are doing week 2 stuff. So assignment 3 this stuff we'll do next week. We'll be introducing limits now, and then we'll go assignment 3. Because last week was week 1. So I'm going to do questions from assignment 2 this week, not assignment 3. So please someone tell me how to plot this one. So do you remember how did we plot root x and all the transformation? You liked, this was your root x function, right? Similarly, so 4 minus x, so if we change this to f of 4 minus x, so it's centered about 4 and going in the opposite direction, right? So if you have values you can't have values greater than 4. So from last, this is your f square root of x. So this will be your fx is equal to root x. So fx is equal to, so I'm plotting here 4 minus x. So 4 minus x can also be written as f of minus x minus 4, right? So we had seen if a function is having a negative value, so it's centered about 4. So x minus 4 would have been this. So minus was take the mirror image. So for example, this will be this. Right? Minus at 4 it is 0. At 0 it is 2. And at minus, so you'll have higher values. So this is your f of, this is root over of 4 minus x. Next, you shift this upwards by 2 because it's 2 plus 4 minus x. So it's 2 plus 4 minus x. This is 4. Let's see, let's plot this using Desmos and see if it is matching. So 2 plus square root of 1 minus, or rather 4 minus x. It's matching, right? So
Yes, sir.
this is the, so yeah, so if you follow simple steps, so I have told you basic graphs. From the basic graphs, you do transformation. So what was the transformation that I did? I did this transformation. minus of x minus 4. This is one possible transformation that you need to do. So you will draw 4 minus x plus first, and then you would flip that about the y-axis. Not about here, actually about 4, because your new center is, so I told you last time, right? So if your function is f of x minus a, so your graph shifts to a, right? Last time I told this is very important to learn calculus. You'll be needing this all. This is the transformation. Your graph, if your original graph is this coordinate system shifts to a. Next, if you have f of minus x, what happens? Your graph is flipped about the y-axis, because for all the values of minus x you would have the same thing. But here, since your new center is a, it will be flipped about y is equal to a, right? Your new y-axis is y is equal to a, not y equal to 0, because you have shifted your coordinate to y equal to a. This is the idea. So you have to always write these in terms of f of x minus a, f of minus of x, and so on. This is the basic idea. If you get that, you can plot any function. So if you haven't seen the previous video, so you can go back and see that video. It will be helpful. So let's see trigonometric functions. For example, I'll do one of them, because just for the lack of time I want to go to, let's try. So trigonometric functions, you see they are periodic, right? So f of sine x, for example, sine of x plus 2 pi, so it's 0 and this is 2 pi, is your sine x. They repeat. So they are not many, they are not one function, or they're not one function to be exact. So how can you get inverse? Can anyone give me some idea? So you see the horizontal line test is failing. So what do we need to do? We need to select, like in the last case we selected one region of this that was not flipping. We need to select one region, that is a fundamental node. For example, from minus pi by 2 to pi by 2. If we select this, now it's 1 1, right? And I have all the values.
Yes.
So I will draw that sine x between minus pi by 2 and pi by 2, and then take the inverse using the this is 1, and this is your minus pi by 2, this is your pi by 2, this is your minus 1. So I sort of flip this. So if I flip this becomes something like this. I just need to be careful about the domains. So your domain will become, I'll flip this and invert y and x. So it's minus at 1, sine inverse, this is known as sine inverse x, will return pi by 2. At minus 1 it will return minus pi by 2. That's the idea. So that's right? So if we put sine inverse of minus 1, so what would you expect? Minus pi by 2, minus 90 degree to give. So if you put sine inverse of say half, you would require 30 degree from it, or pi by 6 from it, and so on. So you flip it and you take up principal component of this. So tan is very simple, you can try it. Cos also. So I'll just write it, sine inverse is between minus 1 and 1, this is between minus pi by 2 to pi by 2, right? This is how we'll define this function. And sine inverse all have to be defined like an inverse table sort of a thing. Similarly, your number 2 part. So can you tell me a principal area where it does not repeat? So again, so these are the tricks that you need to employ for doing this stuff. This is the region. Here you cannot directly take the mirror image about y equal to x. You have to be a bit careful. So you see between 0 and pi, if you take, this is cos x, right? At 0 it's 1, at pi it's -1, and so on. So your function would be, your cos x, I would cos prime x some way, I would write between 0 to pi mapped to, this is between 0 to pi, mapping between 1 to or -1 to 1. This is same thing again. So -1 to 1 would be our domain set for cos inverse also, and our range would be between 0 and pi. So how do I do this? So at 1, what is the value? So if I put in 1, what is cos inverse? Should be at 1 it's 0, right?
0.
Yes. At 0, if I put value of 0, when is cos theta 0?
Should be 1.
Pi by 2.
Pi by 2. Cos pi by 2 is 0.
Is 0.
Yes. So, and cos pi is -1, right? So this will be something like this. This is also a shifted. So you see, this is also a mirror image, but it is across this line. So you may have to shift those lines according to the region that you select. Y equal to x and y equal to -x may be shifted according to your region of interest. So this is your cos inverse. So this is how you define stuff. So even for tan, tell me, somebody go ahead and tell what would be the, so the range and the system for the pi. So what would be the domain and the range for pi?
Same as tan.
Yeah, it's tan. Yeah, correct. So it will be tan, right? So between it's not, tan is between -infinity to infinity. Tan theta is defined as -infinity to infinity to -infinity to infinity, right? You can see from the graph. So these would be repeating for tan theta like this. They are all periodic functions, but we can't do that. We have to take a principal part of it. Say let's say -pi by 2 to pi by 2. So for example this. So if I do that, I can again use our, here since it's about y equal to x, I can use my y equal to x flipping idea, and I can get something like this. So this is your tan inverse of x. So this is between -infinity to infinity, but this will be between -pi by 2 to pi by 2. Is this clear? So at pi by 2, tan theta is not defined, but it goes towards, so this is your tan inverse of x. So at infinity, your tan inverse will give you pi by 2. At -infinity, it will give you -pi by 2. That's what I have drawn. This is how you can go about and do cosec theta and so on. You will be having to do the same thing. So this is between the range, this domain would be -infinity to infinity. The range would also be between -pi by 2 to pi by 2. So you see, an interesting thing is the period is always always pi. You have these functions always have a period of, in this case, pi. After that, they are seen, since you are taking from -pi by 2 to pi by 2. After that, it will be repeating. Essentially, these parts will have a many to one mapping. So let's see. So since now I have defined this function, so I would let's do this part. So let's see, putting everything together, what is the domain and range for this function. So I would require, can anyone tell me, or we would I would do it. So do you see the problem? So there is a domain that this function will be satisfying. For example, this root is only takes values from r plus and maps to r plus, that we have seen. For negative values, roots are not defined, they're imaginary numbers. So x can be anything. So what should be the value of x that this function can take for this function to be valid? So the square, sine inverse and all these things you will have to use. So I'll tell you, remember, I think you know the function of log x. The log x looks like something like this. It's defined from r plus to r, that is between 0 to infinity. For negative values, log does not make any sense. It's the inverse of exponential function, right? So this is the exponential e to the power x function. So you take the inverse of that, so you get log x. So it's also a y equal to x line in this thing. So anyways, so what would be the domain and what would be the range? Let's try this. So what did I say? This is the hint. You see the domain backwards, and the domain set should be a proper subset of the range set of the previous function. So sine inverse, what does it map to? Sine inverse maps to minus pi by 2 to pi by 2, right? Is there any doubt about that? I hope there is it, right?
No, it is correct.
Yes, sine inverse always maps to
Minus pi by 2,
yes.
pi by 2.
But what does your domain of root has to be a subset of this, right? You can't take minus pi by 2 to pi by 2 only in the root. So you cannot take minus pi by 2 in the domain of this function.
So it should be 0 to pi by 2.
Correct. So you will have to select a subset for this. For example, 0 to pi by 2. So you'll have to go backwards in this way. So you selected a subset, and now you tell me which part of sine inverse maps to 0 to pi by 2. So which is this region?
0 to 1.
Correct. Between 0 and 1. So 0 and 1 this is the way you go backwards. So since this is r plus, I only selected r plus. So now it's between 0 and 1. 0 and 1 of sine inverse will map between 0 to pi by 2. Now, the next question is, between 0 and 1, you would want log to map between 0 and 1. That's the between 0, so log of x should be between 0 and 1, right? So what are the values of x that it can take? What would be the subset? Log can take r plus, but I need a subset. So so this is both are held. So this is natural logarithm. So
1 to e.
correct. So log x we have to see equal, since it's an increasing function, you can just plot for two values. So log of x is equal to 0 means x is equal to e to the power 0, this is 1. Similarly, log x is equal to 1 means x is equal to e to the power 1, which is e. So this becomes 1 to e. So this is very simple things. People may give you very complicated problems in machine learning and so on. You would be given very complicated problems to think about, but this is for an application point of view also, this is very simple. Just think about how you go backwards. I've written down the steps. You go backwards and you find proper subsets in the domain, and that would, so here f of g of h is a map from 1 to e, and what is the range set? 1 to e would be between, so this is the map, right? Last step would be between root over of 0 to pi by 2. This is between 0 and root pi by 2, right? This is the answer, right? The range is if you have a doubt in the range, so range would be the last step. So this is the domain of the function in the last step between 0 to pi by 2, as we had pointed. So you apply the function on that to compute the range. So you would get 0 to root pi by 2. So now we have almost got to 1.5 hours. Now we come to the limits that was the central discussion of this. So you can read this definition. So what I'll do is I'll give you the intuition behind what is limits. We will do the epsilon-delta formation for limits, and in the next class, which some of you are asking, we would do algebraic things. So epsilon-delta is very interesting because it gives you an idea. Let's see. So look at this function. So you see at A there's a jump, right? As we had seen in the previous function where I had plotted. There had been so many jumps. Where is that function? Yeah. So there are so many jumps, right? From here it's jumping downwards, from here it's jumping upwards, here to here it jumped, here it is jumping, and so on. So these are not a continuous function. But let's say a function is not defined at a point. So what do we do about it? For example, here, does the function approach a particular value in the neighborhood? The limit asks whether a function approaches some value in the neighborhood. So, for example, if you see from the right, if you go towards A, as x tends towards A, this function goes towards this value, right? C, f of x, say, goes towards C. This is rough notation. I'm going to go to what is the actual notation. Similarly, this is also known as the left hand limit. This is the left hand limit for obvious reasons, the left side. Similarly, if you are coming towards A from the right, say this is right hand limit, does it approach the same point? If it approaches the same point, it means that if a point is here in the neighborhood, the function is always coming to the same point, which means the function is stable. If limit exists, and if the limit is not infinity, limit exists, then function is stable at that point. It's not blowing up. It's not going to infinity. There is no discontinuity. So you can do normal mathematical stuffs that we'll be seeing. So here you see there is a jump. LHL is not equal to RHL. So in this case we say limit does not exist. These are like +2 we followed this convention. But today we'll not do that. We'll do the more theoretical understanding of limits in the form of neighborhood. And we'll solve some questions to understand how it helps. So I'll give you this definition, the right hand side of it. How can we define it formally? So I tried to draw this very, very neatly. So this is you can read this. So does the function converge to some particular value in the neighborhood? If yes, that is the limit of that point. So this is the basic idea that everyone needs to understand. So if you understand that as you are approaching with some x, if your function is also approaching a particular value and not changing, like for example, I'll give you an example, it will be very easy. Sine of 1 by x. As x tends to infinity, does this approach a particular value? It approach as, or you can say as x tends to 0. Does it approach a particular value? Okay, I'll come to that. We'll discuss that then. How is this stability? We'll discuss this. So for example, this graph, so let me redraw it. This is for your notes. You can go through it. This will be shared and you can go through it. And I've also written a very nice game that you can play with questions. I'll give you that definition also. Let's do that again. Instead of looking at I hate looking at slides. So let's do it once again. So for example, the epsilon-delta formulation. So say you have a graph like this, right? And you want to say this is your value x, or say your point A as I defined my definition. So what is the limit that you want? So as I was telling, you need to come towards A from both sides. Let's say you came very close to it and you are in the delta neighborhood, and say A is not in the domain of f. So it can be in the domain, it may not be in the domain, but we are taking it's not in the domain. If it is in the domain, we can just directly plug f of A, that is the limit, right? For example, x square at 2, that's limit will always be 4. But say A is not in the domain, but we want to understand at A what is the dynamics of the system. There can be a point discontinuity, say this point is not defined and it may be somewhere here. This is also a valid function, right? There is no many to one mapping or something like that. One to many mapping. There's nothing something like that. So this is known as a delta neighborhood. Delta neighborhood. Sorry. So now you see in this range, this I'm writing this as say delta of A. So D neighborhood of A. So this is the notation I am following, which means it is between A minus epsilon, A minus epsilon to A plus epsilon without A. So everything in the neighborhood of A leaving behind A is your A delta.
That is open interval.
Yes, open interval. There are reasons I'll show you today in one of the examples. So if you do not have open intervals, there can be trivial cases which people may like fall into. So greater than equal to's are very difficult to deal with. So sometimes open interval is always very safe to deal. So that's why you are dealing with open intervals. So this is your f of delta A, this region. So limit would be, what would be the intuition for limit? So the intuition would be, say you have your limit is L and it's somewhere here. So your limit must not jump. Your limit must not jump in the delta neighborhood of A, however small the neighborhood is. So books and other things would give you all this theoretical understanding, which I find very difficult to understand until you understand the exact definition or exact picture of it. So this is your epsilon. Your limit must not jump in the neighborhood. So what does it mean? F of delta A must be between L plus epsilon and L minus epsilon. So this is the idea. However small your delta and epsilon may be. To read it is delta and epsilon should be close to 0. So if that is true, its limit is not jumping. But this is
It's again open interval, right?
Yes. In the open interval. No, this is also an open interval. So you can write this as f of. So don't go into closed intervals here. There's just a lot of housekeeping problems there. So this is the thing. So you can write it as a mod thing. So you're saying that in the neighborhood of the point, your function must not jump beyond a epsilon. So in the delta neighborhood, the function must jump very small, in very small amount. But now how do we prove things with this formulation? This is the intuition. So I have written the game that we will play to prove this. Let's play that game. So the game is, so say I give you an epsilon, any epsilon I like, or you select an epsilon, whoever wants to, either of us selects an epsilon. Whether I am able to find a delta greater than 0 such that this condition holds is the game we'll play. If we are able to find delta for all epsilons, which means there is no jump for any epsilon, right? So the idea is, if able to find delta for all epsilon, which means there is no jump. delta greater than 0 and epsilon greater than 0. I hope this is very clear now, crystal clear. I've explained it in the picture, so all combinations would be exhaustively seen. So maybe the theory is clear, but practically how do we do it? Let us do this question. It will be a very simple question. I have written down. So for this you need to choose a limit. That's the only drawback of the epsilon delta thing. It's a mathematical tool to formalize limits. It's not a tool to find limits generally. So it's a big tool to prove, to understand the intuition, but it's not a process to compute limits. So here you can compute the limit here. So what is the value of x plus 1 root over? It's 2, right? So I told you, so let us choose L equal to 2. There is no problem in choosing L equal to 2 because that will be the limit. We know that in this case. And then prove that the limit is 2 using the epsilon delta formulation. So this is a guess. So, and your epsilon delta will tell you whether your guess is valid or not. So this is your step 1. These are the steps that you need to take. You may need to make a guess. If anyone is having any doubt, you stop me immediately. This is serious stuff we are doing. So this is 1 is the guess that we will take. So what would be the equation now? So let's see the working.
Can you interpret this one that it is a mapping from delta to epsilon instead of epsilon to delta? So
yeah, we can do that way also, but we'll do a question, but it's the other way around. So if you can choose for every delta and epsilon, so vice versa is also true. But epsilon is there. Epsilon is, since it's a 1-1 map, there is no many to one mapping here.
Right, sir, right.
So you can do that. So let's see. So for example, so I told you this is the formulation for all x in the delta neighborhood of 2. That is, x belongs to 2 minus epsilon or 2 minus delta to 2 plus delta, leaving out 2. So let's do it. So let's just put the values, just definition. So it's x plus 1 less than L plus epsilon less than L minus epsilon. So L we have chosen to be 2. So let's, step 2 would be choose an epsilon. Why we can't do the opposite is, in this case is here. So you choose an epsilon greater than 0. So any arbitrary epsilon that I choose. So this equation is valid then for that. If this is true, right? So for the limit to exist, this must be true. And we need to find delta for which this is true. That's the idea. So let's see. So what we need to do, if we can do something like this, x is between some a and b, we would be likely able to get deltas, right? So this is your, because x here is between 2 minus delta to 2 plus delta, leaving out 2 minus 2, something like this. So let's do it. So how do we do it? Can anyone suggest? So if we can make x the subject of this problem, we'll be able to solve this. So just squaring all sides. So x plus 1 would be 2 plus epsilon square, and it will be 2 minus epsilon square, right? So x would be between 2 minus epsilon square minus 1 and 2 plus epsilon square minus 1. So this is which is also your 3 minus 4 epsilon plus epsilon square, or you can write this as 4 minus 3 epsilon is x is equal to, yeah, correct. So this is not 2, right? So its limit is 3. So just, you didn't remind me. So we are taking the limit at 3. So I had copied the problem wrong. So this is your 3 4 epsilon minus epsilon square, and this is your 3 plus 4 epsilon plus epsilon square. This is the thing. So this is your values of, so if you can guarantee a delta between these two, then this is true, always true. So for example, for values of x between these two, this condition, if this is true, star is true, right? So from, but, and also in, and we also,
In that case must be there be a delta, obviously.
yes. So we'll be able to find a delta somewhere here. If we can find a delta somewhere here, so that should be a subset of this set. So we can do something like, so if delta is minimum of 4 epsilon minus epsilon square and 4 epsilon plus square, which is nothing but, say, which would be this one. So this is epsilon is greater than 0. So this would be the answer. So 4 epsilon minus epsilon square. So you can choose this delta, and you will always be between these two range for x. So your delta would always be a subset. So x here you can write, so you can always choose a closed form for delta as 4 epsilon minus epsilon square. If this is your, and also 3 is there, plus 3. I forgot to write that, since 3 is a constant. So if you choose this, then it's done for you, right? So if this you get,
That means that for every epsilon there is an image delta.
yes. So this is your delta. So you have found a particular delta for it, for that epsilon, for any choice. So now since you have able to find a delta for it, since there is an epsilon, so this image is true. Since for a particular epsilon you will always be able to find a delta. For very small epsilons also you will be able to find a very small delta, which means there is no jumps. That's the idea. So I'll do a few more questions. Another very nice question is this one. So there are a lot of algebra questions. F of x plus g of x, limit would also be f of x plus g of x, limit of increase. And this one is a very interesting question that I would try and show. So we all learnt in our school days that 0 by 0, infinity by infinity, all these limits can be infinity 0 or they can be even some real numbers. They can be. But why is it? Can we prove it using some epsilon-delta method? So here, can anyone tell me what would be the limit of f of x if this is to hold? There's only one value of f of x at x is equal to 0 for this limit to hold. So this is one of the assignment questions that you people have. Correct, A. Since the denominator is A, 0, your numerator also has to be 0, right? So numerator also has to be 0 at when x tends to 0. This is the idea. So you need to have a 0 by 0 form. So any constant by 0 is infinite, will tend to infinity. So the numerator will have to have a minus f of x will be equal to 0. So it will give me, so this is your class 12 way of writing this solution. F of x is equal to a. And once you know why it is true, you can easily do that as well. Not a problem, not a big deal. So, but the actual epsilon delta way, how do you do it? So, since now we would say the limit is valid, right? The limit is valid. So, you're given the limit value. So, you need to find a delta and an epsilon formation to show that it is true. So, let's do that. So, let's write a definition first. 1 plus no equal to epsilon and 1 minus epsilon. Is this definition right? for x in the delta neighborhood, that is between x between minus delta to delta, right? Delta neighborhood of 0 is minus delta to 0 delta, delta minus delta minus 0 minus delta, 0 plus delta. This is true, right, for that?
Yes, sir.
So it's between 1 plus epsilon and 1 minus epsilon. So for this to be true. Now, you can rewrite this. So what will it be? Let's rewrite it as some function of f of x. So we need the limit of f of x. So this would be 1 plus x epsilon. This is for x greater than 0. Just remember that. Because we are multiplying x throughout. If we multiply x for x less than 0, what will happen to the inequalities? They will flip, right? Yes. So this is for x greater than 0. I multiply the x. Cross multiply. Right? This is a valid argument. And this is minus f of x. And I send a both sides. So is this step clear? And then I multiply f of minus. So I may get f of x between a minus 1 minus epsilon x and between 1 plus epsilon x, a minus 1 plus epsilon x. Is this clear? This is for one case. The other case would be for x less than 0, where the inequalities would flip. Now if you have doubt, you just stop me here itself. So you would get f of minus x, inequalities flipped, 1 minus 1 plus epsilon x minus a, 1 minus epsilon, same equations, just inequalities are flipped because x is less than a. There's nothing too complicated. A minus 1 minus epsilon. So just a second, did I change the inequalities correctly? This is less than, so this is x is greater than this, so yeah. So this is a minus, so you multiply this, so you get a minus 1 minus epsilon x, and you get here a minus 1 plus epsilon x. Is this all right? Just rewriting the equations in a particular way. Now what do I do? Since we know for every epsilon it holds for every delta, right? For all x between, this holds for all x between 0 and delta, right? This is always true. So if I put delta here, this is an upper bound to this part. If I put delta in x here, this is an upper bound. This is, no, sorry for that. This is not valid. This is lower number. This is a lower bound. If I put delta here, this is true for all x between 0 and delta. If I put delta in x on the left hand side instead of x, so this is a larger number. Delta is greater than x, right, in this range. So minus delta would be lesser than that. So do you agree that 1 minus 1 plus epsilon delta would be this for all values of x between 0 and delta? Would you agree to that? Similarly, for x greater than 0, if I put minus delta here, x is equal to minus delta on the right hand side, it would be an upper bound, since you'll get some number greater than this upper bound. You'll get something greater. So a plus 1 plus epsilon when I put x is equal to minus delta. Now I see a lot of confusion, so you can ask if you have a doubt. So and this side will not be valid. So f of x would be between, there may be some x is 1 plus epsilon, it's lesser than that, and this is greater, right? And here also, yeah, this is correct. So x would be between a minus 1 plus epsilon delta, between a plus 1 plus epsilon delta. So this can be your next epsilon prime, right? Epsilon prime. So now you have fx minus a less than epsilon prime. So your limit is proved to be a. Isn't this very elegant? So if you, the only catch is putting this delta here. So if you can get that catch, it'll be easy. So if you have doubt in this step, you can ask. I can try to answer. Anyone with a doubt? So what I did is, for all values less than delta, this is true. So if I put even a lower bound, if I put a number lesser than this, then also it is true, right? So if I put delta is much greater than that x, so in that case I will give getting that a smaller bound. Similarly in here, if I put a number that is much greater than the right hand side, so similarly I can get an upper bound. This is just manipulating epsilons and deltas to get this value. So now this will be your so discontinuity and so on. So we are almost to the end of the class today, but we'll do a couple of very fast solutions. So can anyone tell me if limit, let's draw 1 by x first. This is your 1 by x graph. Limit does not exist clearly, right? Yeah, you can see this session on YouTube. You can subscribe to my channel for this what is it called, NPTEL channel, for this 12 weeks and see. So I have shared the links of YouTube. I'll share it at the end of the class today. I just don't want to break the flow. We had a lot of interesting stuff today. You can go back and check and find out. If you have any doubt, ask me next class. So 1 by x limit does not exist. See, at x 0 plus it is infinity, and 0 minus is a negative infinity. Roughly speaking, you are dividing by a negative small number, so it goes to minus infinity. You are dividing by a positive small number, goes to positive infinity. Now how can you prove it with epsilon delta? Let's prove it. Say let's the limit be L. This is the hint. So what will be the, someone come and tell me how to write the definition of the epsilon delta? So we wrote like this, right? F of x minus L less than epsilon. This is the, or f of x is between L plus epsilon to L minus epsilon, right? This is the definition of epsilon delta. So this should hold for all x in the minus delta to delta, right? This is because 0 neighborhood. This is equal to delta neighborhood of 0. Now can you give me a counter example to show that it does not actually belong? There is not, for a particular value of epsilon there is no delta. I think there is a very nice counter example that you can see from this. Can anyone come up with a counter example? So to disprove limit does not exist, counter example is enough. So this would be your work at home. So this is both of these. I'll just draw the graph. Both goes to infinity. So you can say the limit is infinity since both left hand and right hand limits are infinity. Some book says limit is infinity. Some book says it is not defined. So because they don't define, they don't talk about infinity. So you can tell either. But in this case, limit does not exist, since there is no neighborhood. This is your, so tell me, how do you get? So if I take epsilon is equal to L, for example, so what do you get? F of x is between 0 and 2L, right? But can you find a delta such that a negative number is there? So f of x is nothing but 1 by x, right here. So can you find a delta? So for any delta between, this has to be true for all delta between plus minus delta to delta. So there is no, if you put x is equal to minus delta prime, that is negative, to this, does this hold? It does not hold, right? This equation does not hold for this. Okay,
So we are not getting at all any delta.
yes, you are not getting any delta for this epsilon.
corresponding to epsilon, right?
Yes, so if you do not get any delta corresponding to epsilon, such that both, so for every delta you will have some negative values, but here you will have no negative values for of 1 over x. So any delta you choose, that has to, this for this x, those values must hold for all those deltas from minus delta to plus delta. So but if you put minus delta here, this becomes a negative number. So this is a contradiction. This is the epsilon delta way of proving this. Similarly, for x by x, what is this function known as? Can anyone tell me? Or how will it look like? Can anyone tell me? Let's write this function. So f of x is mod x by x. Yeah. So I see
That is a sigma function, signum function.
Sine function or the sigma function. Sine function. So what does it mean? So it's x by x for x greater than 0, not defined for 0. I'll not define it for 0. 0 by 0 is not defined.
For it to 1.
And less than, this is equal to 1. And for x less than 0, so it's equal to minus 1. And sometimes in books, you are in computer science, you define at x is equal to 0 as 0. Just by definition. So your x is equal to 0 is 0. At every value of negative values is minus 1. And every value of positive is plus 1. So you see, now I'll give you graphical ways of seeing if limit exists or not. Does this limit exist at limit x equal to 0? See, there's a jump. So on the left hand side, left hand limit is minus 1. Right hand limit is plus 1. So limit
1.
Limit
Does not exist.
So limit does not exist. So you can always find an epsilon delta similar proof for this. But I hope that epsilon delta formulation is also clear. This is also clear. So I have the epsilon delta proof for sandwich theorem. I had written it down just for one reason, because I thought I would not be able to cover this in this class. So I hope I'll request you all to look at the proof. I've written a very simple proof for the sandwich theorem using epsilon delta, and I'll do some questions in the class instead today. Let's see the intuition behind sandwich theorem. So what is sandwich theorem? Go ahead. Yeah, Suraj, go ahead.
Sir, my question is limit, sir.
Okay.
Limit extend to 0 plus
Huh?
fx is equal to a.
Huh?
Limit extend to 0 minus fx is equal to b.
Yes.
So limit extend to 0 plus f x cube minus x is equal to what?
F of?
X cube minus x.
This is the third assignment question, right?
Previous year, sir.
So it's third assignment question.
Previous year, sir.
No, I'm asking, is it third assignment or second assignment question?
Third assignment question, but previous year question, sir.
We are in which week? I'm just not able to understand. I told you once, right? I'll tell you next week. That's the way we go about stuff. We don't jump. If I have time, I'll do it. No problem. And if you have any questions, you can directly write a mail to me. I'll do it for you. No problem. Let's do things one after the other. Then we'll do it. Previous year is, I can understand it's a previous year question, but it's still the third week question. We are in the second week presently. It's just the second tutorial we are having. Anyways, so say you have a function g of x and an h of x such that a function is always sandwiched between that is f of x. See, so f as I have drawn is between g and h, right? So if at a particular point you have this limit limit gx equal to, say, c at a limit x tends to c is a, is equal to limit h x tends to a, then the function in the middle, f of x, will also have the same limit, right? Its middle is in between, so both of them are in the same neighborhood. The middle function also has to be in the same neighborhood. It cannot jump because it is bounded up and down by both this function. This is the intuition behind the epsilon delta proof that I have done here. You can look at it and ask if there is any doubt in the next session. It's very trivial proof, but is the intuition clear? So if a function is between two functions and two functions touch each other, the top function and the bottom function touch each other, the middle function will also be touching that point, right? It cannot be above and below, otherwise this condition will be violated. If it is below, then it will become less than g of x. If it is above, it will become above h of x. So for example, here to prove limits, to what do we need to do? We need to select two functions and show that this function would be correct or wrong. So this one I won't do today. So I would maybe solve it in the next class. But this one I will do it just to show how to prove sandwich theorem. So can anyone tell me what to do? So how to prove that limit is 0 at x is equal to 0, sine of 1 over x? There's a very simple answer to it. So for example, what is sine bounded by?
-1 to 1.
Correct. So if I can, so this is a function g of x, right? And this is your function h of x, and this is your function f of x. Now it's not exactly f of x, so we'll have f tilde of x, g tilde of x, and h tilde of x. What do? I multiply this with x square, so I get minus x square sine 1 by x. So x square is always greater than 0, so I can always multiply without changing inequalities. So this is your sandwich theorem equation, right? So this is your f g of x less than f of x less than h of x. Now if we can show at x is equal to 0 these two limits are 0, then this also will have to have 0 limit. So limit x tends to 0, minus x square is indeed 0, you just put value of minus x square, and limit x tends to 0 plus x square is also 0. You put the value of 0 there. So what would be this limit? This will also be 0. Since the top limit hx is 0, limit fx or gx is 0 as x tends to 0. So limit fx is also 0 as x tends to 0. This is the idea. And this is your homework. I'll tell you how to do. This is your sigma function or the step function. So what you do is, this is the integer value, also known as the integer value function. Here, your between 0 and 1. So you will have so for example 2.65. You do the integer value function. What will you get? You get 2. You do minus 0.67. What do you get?
-1.
Very good. Because see the definition, max of values, integer value less than that value. So -1. This is also known as the staircase function, and so on. So you can use this. I'll give you the hint. So you can use. Can anyone tell me what can it be upper bounded and lower bounded by?
0,
No. You see, for example,
x minus 1 into x.
yes, that's right. This is x and this will be x minus 1, right? Did you understand? So if it is 2.67, so you would get f of this function would be 2. But if it is 2, it will also be 2. And similarly down, and x minus 1 is always less than that function, right? So you take 1.99, you subtract 1, so you get 0.99, which is less than 1, which is the function. So you use this to find, you put this, find the, this will be your g of x, this will be your h of x, and then find these two limits. You will see this answer will be most probably x square by 2, as far as I remember. So this is
Yes.
the hint. Yeah. So this is a very nice way to do it. So anyways, so now Suraj, you can ask what your question was. And if anyone else has question regarding today's session, you can ask first, then we'll do his question. So we covered composite functions, inverse functions, and limits. So we have seen definitions of limits, algebra of limits we will do next day. That's, many of you have questions in that. Yeah, so go ahead, Suraj.
Okay, sir. Thank you.
Now go ahead, ask your question, Suraj. So limit,
Yes, sir. Fx
yeah,
a
yeah, then
x cube limit
limit x tends to 0.
extend to 0
Then
plus fx
fx,
x cube minus 1
after fx I can't understand what you're saying. Can you write it down?
no sir fx cube minus 1
Fx cube,
g minus 1
okay. This one, right?
yes sir.
So you're asking what function will it be, right? So
Yes sir.
at 0 minus, you're having some limit like this, say b, and you're at 0 plus, you have some limit as a, right? Is this okay?
Yes sir.
Okay. So if I put value of x plus here, so what do I get? F of 0 plus cube, right? So it's a positive number, minus 1, right?
Yes.
So this is f of minus 1.
Yes sir.
So nothing has been told about f of minus 1, right? So your answer is f of minus 1.
b
No, but is it a constant function? In the
Not
question,
constant function.
it's a constant function. So this means this is like this is like this. So then it's f of minus 1 is b. Right?
okay sir.
So it's a constant function, means, see why this is no question actually. So this is just to show this jump, and since this is x cube minus 1, so you can put values of, if this was 0, f of 0 would come up, then you could not have told anything about it, since this is jump about 0. Are you Mahamrityunjay, are you telling me this is to me to solve?
Sir, fx x square minus x to the power 4
Huh? Hello?
x limit. Next question, sir.
So I don't think we'll be doing all questions like this, right?
Yes sir.
But anyways, next class if you have doubt we can do it, but I don't, Mr. Pandey had some doubt. What? Question 5? Can you go ahead and type it or tell
Yes,
me?
sir. Hello.
Yeah, go ahead.
Limit x to
Limit x tends to 2.
limit x tends to 2. Yes, sir. In bracket x square
X square.
limit gx limit x tends to 1 gx
This is your
this is your
x tends to 1.
x tends to 1 gx
gx
is equal to 2.
equal to 2.
Then find the limit of x tends to 2, gx minus 1.
Okay. So this is a function g. Right? So at
Yes, sir.
can you mute? Yeah. So at x is equal to 2, this is a constant thing, right? Look at this. So f of this function at x square, you can directly put this value. It will become 4. X square is a continuous function like this.
Yes.
So it's 4 limit x tends to 1. This is simple algebra. It's nothing in it. 2. So limit x tends to 1 is your g of x 2 by 4, right? Half, right? Correct? Hello? Yeah.
Then what is the limit?
Yeah, are you there?
Tends to 2, gx minus 1.
Yeah, so now you put the value of 2, right? So here I can write, are you there?
Yes, sir.
Yeah. So I can put x minus 1 tends to 1. Replace this variable by this. So you get half. Okay? Is that okay?
Yes, sir. Okay.
I think you are having echo, so it's okay.
Got it. Yes, sir. Yes,
Previous
sir.
question 0 minus
Huh?
0 minus, sir.
In this one, if you put 0 minus,
Yes, sir.
same answer, because it's still f of minus 1. If you have
Okay, sir. What? 0 minus, sir.
0 minus q, what is that? That is minus 0 minus only. Some negative number very small. If you subtract 1, you still get minus 1, number tending to minus 1. You still have, you are in this part. Is there any difference? It's some number greater than 1 you will get. Greater than minus 1. This will be minus 1 minus some number less than 1. Minus 1. That's it. So still 1 since it's the unit functions. Okay, we have sort of over. Do you understand?
X cube minus x, sir. Yes, sir.
Is this number 0 minus or plus?
Yes, sir.
Is this 0 minus or plus? This number is negative, right?
Yes, sir.
So this is 0 plus and this is your 1 minus 1. So this would in turn be 0 minus. So this is your limit tends to x tends to 0 minus, that is b. Do you understand? X cube minus
0 plus multiply by minus 1.
minus 1, right? This is a negative number. X square is positive. For any number, this is a positive number. So limit x tends to 0, right? X tends to 0. 0 plus. So this is a positive number. This is a negative number. You agree to that, right?
Okay, sir.
What is
0
x
minus, sir?
X cube minus 1. What is x square minus 1? That is 0 minus 1 if you put the limit at that point. What is that? This is minus 1, right?
One.
So minus 1 into 0 plus is what? 0 minus. Say if you do not want to take h, 0 plus, you can take h plus h. So plus h into minus 1 is minus h. So minus h tends to 0. So the actual way to write is this: limit x tends to h, limit h tends to 0, or h plus. So h, so this is f of, so this is limit h tends to 0, this is your h plus, this is a negative h minus half. So you put another this is a very number very close to 1. So how do you write it? So this is very close to 1, you get minus 1. This one you can sort of take the limit inside and put 0 here. So you get 0 minus 1. So this is f of minus h, limit h tends to 0. So this is nothing but limit h tends to 0 minus f of h. Did you understand why it is b?
Okay, sir.
Did you understand? It's not okay.
No,
Yes,
sir.
by the definition itself.
This is the definition, right? You have defined
Yes,
as 0 minus as b.
sir, sigma.
What is sigma here?
Silent sigma.
I'm not understanding what you're saying. Where is sigma here?
Sigma epsilon. Epsilon sigma. Sir. Next.
I'm sorry, I can't hear you.
1 minute, sir.
Sir, can you pin you?
Sigma epsilon definition से sir.
Sigma delta epsilon delta you're saying.
Delta epsilon.
I would request you to I don't understand what you're telling me. So this has to be done with algebra, with sigma delta epsilon proof. This will be a huge task. I don't think this is a sigma delta epsilon delta proof. There's no sigma that we did anywhere here. It's a epsilon delta. It's with algebra that you need to do this, just like we did here. There have been sessions in the course. You just can't do epsilon delta. What did I tell you? That epsilon delta is a way of understanding limits and not solving all limits with that. You can't find limits with it. You have to guess and prove it. What I have done is I have put the value of h here to be 0 and I have got minus h. So which is nothing but limit of 0 minus of f of x, which is by definition b. So you told one question, then you told x cube minus x. So okay. So we'll stop the session today here and then we'll meet next week. We are already 2.5 hours into the session. Okay, thank you.